Okay, so welcome back. So now we are going to move on with problem 3. Problem 3 has an extremely simple concept. Basically, you have a string stored off in flash memory, and then you're going to want to copy that string into your RAM memory. I know that I'm using technical jargon there, but it's the same thing as copying one string to another string. And the beauty about this problem is they told you how to do it. So, possible implementation. So I'm going to read this in English first, and then we're going to implement it together. So step 1, exactly the same as the last one I showed you. We have to give ourselves a link into our data buffer. And then once we have our link set up, we're going to step straight into our loop. So using the link to our test string, we are going to get the current character, and then with that character, we are going to store it down into your data buffer. And then we're going to keep doing this until we reach the end of the string. So before we go ahead and write the code, let me go down here and then show you the kind of memory that we're working with. So test string 1 and test string 2 right here, as you can see, DCB means that each character in the string is stored as a byte. So since we're working with bytes, when we're doing our loads and stores, we have to remember to do it as a byte. So we're going to go ahead and see that here in a second. So let's go ahead and start programming. So step 1, we already said we have to create a link to our data buffer. And remember, the way that we do that is we just use load register, any register we want, and then we are going to link it straight into our data buffer. Once we do that, we're ready to create our loop. So in our copy loop, first thing that we have to do is get the current character, in this case the first character, from our test string. So in order to get a character from somewhere, you have to load it into a register. So we're going to go load register, but be careful. These are bytes that we're working with. So we have to remember to load register as a byte. And we want to store it, and in this case I want to store it in just R2. We are grabbing this through R0 because R0 is what's connected to our test string. After we do this, we have to move over to the next character so we can get it next time through the loop. And since these are bytes, in order to move from one byte to the next byte, you only have to move, surprise, surprise, 1 byte. You see, this is what I mean. If you have a conscious understanding of the data that you're working with, these kind of problems are extremely simple. So once we have our character, which is stored in R2, I'm going to take it and store it, but what do I store it as? I store it as a byte. And I'm going to store the value of R2 through R1 this time, because R1 is what's connected to my data buffer. And then I want to move over to the next spot so I can insert the next character the next time through the loop. And in this case, I only need to move over 1 byte. And then the last thing is just check if you're at the end of the string. If you are, keep looping. If you are, stop looping. If you're not, keep looping. So I'm comparing what's in R2, because that's the character, to the address of 0, which is the null terminating character. And then as long as I'm not equal to that, I can keep looping. So let's go ahead and build and run this and see what we come up with. Okay, everything checks out just fine. Everything builds properly, no issues. So let's go ahead and start seeing the code work in action. So ADR, I meant to explain this to you, but basically ADR works the exact same way as LDR. But the beauty of ADR is it doesn't really care what kind of data you are because it just loads it as it already is. And ADR is not as useful as LDR because ADR can only access your flash memory. And flash memory is something that you cannot change. Those are constants, variables that you are reading but you can't write to. Whereas the data buffer, which is stored off in RAM, you can actually write things to it, as you've already seen. So enough of that, let's keep writing the code. So anyway, we created the link to our test string, and now we create the link to our data buffer. We get the first character, store it to the data buffer. as you can see, we have SPCC, a space, and then CS107. Now the next time through, now as you can see, R2 is equal to the address of 0. That means that we have in fact reached the end of our string. So when I do the comparison, we are not going to branch back to our loop this time. And we're done. We have successfully copied one string to a different string. So as you can see, these problems follow the same pattern. You're going to have the next problem, you're going to find the average of all of the elements in an array, which is the same exact thing. I'm not going to actually code it, but it's first thing that you should do is you should go down and look at your data. And once you know what your data is, then you know how you have to load it and how you have to store it. And then it's just a matter of getting the average. You sum up all the elements and then divide by the number of elements that there are. So pretty simple. You guys will be just fine. So for anybody that was confused on these matters, I hope that these two videos helped you guys out, and good luck on the rest of the lab.